In this video, we're going to look at the antiderivative of a function. Now, the original function is symbolized as f of x. Its derivative is symbolized as f prime of x. And the antiderivative of the function is symbolized as capital F of x. Now, the relationship between the antiderivative, or capital F of x, and the original function is that if we were to take the derivative of the antiderivative, so capital F prime of x, we would equal f of x, our original function. To look at this a little closer, let's go ahead and take the following example, where f of x equals 2x squared plus 3x minus 1. Now we can find the derivative of this equation using the power rule, and we find that f prime of x equals 4x plus 3. Finding the antiderivative is as easy as going backwards, so we'll let the 4x plus 3 equation now be our f of x instead of our f prime of x. And we'll let the 2x squared plus 3x minus 1 be our capital F of x, or our antiderivative equation. An important thing to remember is that the derivative of a constant is always 0. So if we, instead of having a negative 1, we had, like, for example, a positive 2, it would still be a valid antiderivative for the 4x plus 3 equation. So every time we have an antiderivative, we actually make a family of equations instead of just a single equation. And we symbolize that by adding plus c to every antiderivative we compute. To find the value of c, you need what's known as a boundary condition, or some point that we know exists on the antiderivative function. Without that, you do have to leave it as plus c.